So here are some facts about the least squares regression line that we want to keep in mind. We talked about how for correlation the distinction between the explanatory and the response variable didn't matter. You were looking at the relationship between the two variables. But for the least square regression line, it absolutely does matter. It is essential. If you swap x and y, you're going to get the inverse of the line you would get the other way around. So it's very important that you decide appropriately what is the input variable, what's the explanatory variable, and what's the response variable. The slope and r, your correlation coefficient, they always have the same sign. We talked about that with the scatter plots. When you have a positive association, you're going to have a positive slope on your least square regression line. Let's see, this one just kind of a trivia fact really to me. The least square regression line, it may not pass through a single one of your actual data points. You minimize the sums of the squares of the errors, but you may not hit any of the points, or you may hit one or two. But it will actually always go through x bar, y bar, the average of x and the average of y. And then r squared, why does your calculator give you r squared? Well, we call that the coefficient of determination, and it actually tells you something. Okay, the line explains some of the variation in y that's explained by x. Okay, so the fraction or proportion or percent, depending on how you represent the number, of the variation in the values of x that is explained by the least square regression line. So like if r squared was, say, 0.6, then 60% of your change in y can be predicted using x and the least square regression line. Okay, so we call that the coefficient of determination. It's literally r squared, and if we knew r, we could compute it, but since they're both useful, the calculator gives us both of those. Okay. Here's another type of plot that we can make. So the difference between your actual data y value and your predicted y value is called the residual. This is your error that you're minimizing the sum of the squares of these, and they call that thing the residual. So I could just make my regular scatter plot with my least square regression line, but sometimes it's useful to make what's called a residual plot, which is kind of like just taking that regression line and turning it horizontal. But what you're doing is you're plotting your x value versus the residual instead of versus the predicted y values, or versus the actual y values. So it's really kind of the same picture, just making the line horizontal so that you can look and really quickly see the distances above and below that line to see how big the residuals are. So a residual plot is a scatter plot of the regression residuals, y minus y hat, against the explanatory variable. So that's used to assess the fit of the regression line, how far are those things scattered around the regression line. So you look for random scatter around 0. It's a way of taking the line and centering it at 0, making a horizontal line. Outliers and influential points. We talked about how the correlation is not resistant. Outliers greatly affect that, and they greatly affect the least square regression line. So an outlier is an observation that lies far away from other observations. So maybe most of your points follow a nice linear line, regression line, and you have something that's off from it, which would be an outlier. We actually have two directions. We have the x variable and the y direction, and it makes a difference as to what's going to happen. Outliers in the y direction are going to have really large residuals. There's going to be a big difference between your y hat and your actual y value. Outliers in the x direction, we say, are often influential because in order to minimize the distance from the points, it's going to have to follow those that are way off in the x direction. Okay? Let me show you that with GeoGebra. So I'm going to take GeoGebra and throw down a bunch of points, and then it has a tool, a best fit line. I can just select all the points and it'll do the best fit line, which has the equation there. So if you go off in the y direction, you get large residuals. The line's going to move a little bit when I'm moving this point around, but I'm also getting a very large residual. But if I go off far in the x direction, because it's so far out in the x direction, the regression line has to really follow that point. So we say that point's very influential when it's an outlier way out in the x direction.